Indo-Aryan languages are marked by a four-way distinction in the manner of articulation of plosives. To the language learner whose native tongue does not afford this distinction, both perception and production pose challenges. In this work, we present an acoustic-phonetic features-based approach to automatic feedback on the quality of phones produced by non-native speakers. Trained on Hindi native speech, the system works reliably on production data comprising Bangla words uttered by native Bangla and by non-native, that is American English speakers. Here we present the phonetic distinctions between English stops and Hindi Bangla stops. We note that English presents a two-way contrast for every place of articulation, whereas we see a four-way contrast in the case of Hindi Bangla stops, where every voicing condition is further differentiated into aspirated and unaspirated versions. Here we present the target words for the listen and repeat task, comprising of Bangla words. Here we play the first four words as uttered by a native Bangla speaker.
Kala, khala, golla, gholla.
As we know in American English, unvoiced plosives are aspirated in word initial. Also, voiced plosives can become devoiced occasionally. 50 utterances by 4 American English L1 speakers were labeled by native listeners to obtain the following distribution. And we see that our expectations on L1 influence are borne out. A lot of the unvoiced plosives are actually realized as unvoiced aspirated, whereas some of the voiced plosives are devoiced. And finally, the voiced aspirated plosives are not realized correctly ever. Here we have some examples of productions by non-native speakers. The first one is an example of a voice stop in aspirated and unaspirated forms. We will note that the speaker realizes the distinction only by a change in syllable stress.
Basha, basha.
The second word is an example of a voice aspirated stop.
Takhali.
We note that while aspiration is realized, there is a loss of synchrony between the release of the burst and the onset of aspiration, attesting to the complexity of the articulatory gestures involved. Finally, we comment on the performance of a system in automatic feedback. We see while unvoiced and unvoiced aspirated plosives are correctly detected, voicing detection is not as accurate. We obtain a classification accuracy of 68% on the four-way miscue detection accuracy. On the other hand, the detection of mispronunciation itself shows a relatively high recall and precision. Finally, we conclude that we see the potential for focused feedback with training on a much larger data set of perceptually labeled non-native speech.